that we are talking about in this unit is the circle graph. So we're going to talk about some pie charts, which is another name for circle graphs. We want to be able to find percent from a circle graph. We want to be able to find the degree measures as well. And we want to be able to analyze the data that the circle graph shows, draw some conclusions about that given a specific situation. So looking at this pie chart here, or this circle graph, what do we know? Well, the title tells me that this is about favorite pizza toppings. Then my key here tells me what the toppings are. Clearly my options were pepperoni, cheese, sausage, and supreme. And then the actual pie chart tells me the percentages of each topping. Now that's about all I know, right? I don't know who was asked. I don't know how many people. I don't know any of that information. So if I'm given a situation, the 180 geometry students that we have at DDHS were surveyed about their favorite pizza toppings. The choices given were pepperoni, cheese, sausage, or supreme. The results are below in this pie chart here. Now I know a little bit more. I know that there were 180 people who were surveyed. I know that they only had 4 choices for the toppings. So now I can start to answer some questions and figure some stuff out. So the first question that I'm being asked is how many students chose each topping? If I'm looking at, let's start with pepperoni because that's pretty easy. Out of 180 students, 50% chose pepperoni. 50%, remember, is half. Half of 180 would be 90. So 90 students chose pepperoni. Now, looking at cheese, how many chose cheese? 25% of the 180 students. I can set up a proportion for that. Multiply 180 times 25, divide that by 100, and I get 45 students. I could also just know that 25% is a fourth. So if I divide 180 by 4, I get 45 as well. So now I've used up 90 students here, 45 students here. I know that between the 15 and the 10% is going to be 45 total because that's how many I have left, okay? So there's a couple ways I can do this. I could either find 10% of the 180, or I could take the 45 and divide it into 5 parts, and knowing that 2 of them are supreme and 3 of them are sausage. So however you kind of think about it is fine. I'm just going to do 10% because that's easy. So supreme would be 18 students. And then to find the remaining, I could just subtract all these numbers from 180. I could subtract the 18 from 45 since I know that's how many are left. Either way, I get that the sausage are 27 students. So now I know how many students chose each piece. Now the other question here is, what is the degree measure of each piece? Okay, remember that every circle has 360 degrees. That's the total amount of degrees in a circle. I'm going to take these percentages just like I did with 180, and I'm going to multiply them by 360. So to find 50% of 360, I multiply 50 times 360, divide that by 100, and I get 180 degrees. To find 25% for the cheese, 25% of 360, do the same thing, 25 times 360 divided by 100, and I get 90 degrees. The last two are supreme and sausage, and I'm going to do the same thing. 10% of 360 is 10 times 360 divided by 100 is 36 degrees. And then last is the sausage, and that is 15% or 15 times times 360 divided by 100, and we get 54 degrees. So when we create a circle graph, what we're using are the 360 degrees in a circle and the percentages that we know to be able to figure out how many degrees each sector, that's these different pieces, each sector should be. Let's look at another one here. The Milton family has an income of $75,000 and is considering revising their budget to save more money. How much do they spend on each category knowing that their income is $75,000? So we've got some different incomes here. We've got food, we've got miscellaneous, we've got clothes, we've got savings, and we've got rent. Okay? Miscellaneous might be something like entertainment or what would be another example? Gas, that's not on here. There's a lot of different miscellaneous expenses. Those are the things that don't fall into these other categories, okay? So let's start with food. How much are they spending on food? They are spending 33% of their income, which is $75,000, on food. We simply set up a proportion and figure that out. And we get $24,750 on food. Then we can do the same for the rest of them. So let's say rent. Rent is 25%. It seems unusual that you would spend less on your rent than you would on your food. Maybe this family eats an awful lot of food. I don't know. But we're going to set up our proportion again, and then we are going to multiply. And we get that they spend $18,750 a year on rent. Then we look at savings, which is only 6%. That's not great. But we're going to set up our proportion again. Notice how I'm setting up the same thing each time. I'm just changing this top number to match whatever the percent is on the pie chart. The nice thing about this is that you're always doing the same thing. You just have to change the number to match the information that you're given. So when I multiply this and then divide by 100, I get $4,500 is going into their savings. Their clothes would be 15%, so I'm going to put the 15 over 100 and then work with the 75,000 again. And I get $11,250 on clothing. The last thing I need to find is the miscellaneous. Again, we're not necessarily sure what that is. Doesn't really matter. I'm going to take 21% this time, and I'm going to solve again, doing the same process each time. So I'm multiplying 75,000 times 21, dividing by 100, and I get $15,750 that this family is spending on miscellaneous whatever expenses. Okay, so this is their budget broken apart. We can figure out exactly how much money is going to each specific thing using our percentages and then the income that we know. Okay. Looking at another one here, we've got two graphs. First of all, graph 1 is talking about 240 juniors and seniors, and it looks like it is talking about how they get to school. We've got bus, we've got walking, we've got driving, and we've got parents. Then down here on graph 2, it says number of juniors, so just juniors. The last one was juniors and seniors, and this looks like it's also how they get to school, either bus, parents, driving, or walking. And then we've got some statements over here that we need to fill in. So first one, blank juniors and seniors take the bus. So the question is, how many juniors and seniors take the bus? Well, we know it's 40% of the 240 students, the 240 juniors and seniors. Total, we want to figure out how many of them take the bus. When we multiply that, we get 96. Now remember, this is 96 juniors and seniors. I know from my graph down here that 80 juniors take the bus, which means that 16 seniors take the bus. I know this because I know that 96 total take it. 80 of them are juniors, therefore 16 of them, by subtracting, must be seniors. There are a total of blank juniors, so there are blank seniors total. How do I figure out how many juniors there are? I'm going to look at this graph too, which is just number of juniors, and I'm going to figure it out. So I have 80 kids who take the bus. I have 40 kids who ride with their parents. I have 10 kids who drive, and I have 20 kids who walk. Now I'm just going to add all those up. So 20 plus 10 plus 40 plus 80 gives me a grand total of 150 juniors. Now I know that there's 240 juniors and seniors. If I simply subtract that, I get 90 seniors. Okay, so we're using information that we're given from both graphs and we're putting it together to try to figure out some stuff. Now the next question says approximately what percent of the senior population takes the bus to school? Round to the nearest percent. So I know that there are 90 seniors. And I know that 16 of them take the bus. My question is, what percent is that? So again, I'm just setting up a proportion here. I'm going to cross multiply. And I'm going to get 17.77777. This says round to the nearest percent. So let's round this to 18%. So this is kind of common sense. We're kind of just reading these graphs and pulling some information from them to answer specific questions. But you have to think about what you know and what you can figure out. So I know from this first graph how many juniors and seniors there are total. I know percentages that come to school different ways. The second graph I know is just about juniors. So if I take all those juniors out of the 240 juniors and seniors, I can figure out how many seniors there are and then do some work with that. So once I get some information, it's kind of following the path to figure out all the different pieces that I know and putting them together to answer questions. This is circle graphs. Again, we're doing a lot with percentages. You're looking at the key, look at the title, that's really important. Make sure that you understand what the circle graph is about and get a situation if there is one. And then always make sure that you are thinking about using a proportion to do your percentages and figuring out what percents you know, what percents you need to find, and where you can go from there, okay? So hopefully this makes sense for you. We're going to talk about a couple of other types of graphs as well and put it all together in order to do Unit 5. So here we've got another situation. Mr. Cretus wants to bring in pie for the teachers. What a nice guy. So he polled all 98 teachers on their favorite pie. The results are in the chart. So we see this circle chart here talking about pie preferences. There's pumpkin, cherry, apple, pecan, and coconut cream. Ugh. Clearly I was not voting for the coconut cream. The question is, how many teachers prefer pumpkin? We know that there are 98 teachers total, and we know that 30% of them prefer pumpkin. All we have to do is figure out how many that is using a proportion. So let's set this up. Then we are going to multiply, and we end up with 29.4. Can't have 29.4 teachers. So we would round that to the nearest whole number. In this case, the 4 tells us to round the now or leave the 9 the same, not round it. So we would say that 29 teachers prefer pumpkin. Now the next question is, how many more teachers prefer apple to pumpkin? You can see that pumpkin is 30%. Apple is 36%. Now there's a couple ways we could approach this, okay? We could find the number of teachers that like apple by taking 36% of 98 and then subtracting that with the 29 that we already know like pumpkin. Or we know that one is 36%, the other is 30%, meaning there's a difference of 6%. We could just find the 6% of the 98 and solve that way. When we do, we get 5.8, so about 6 more teachers prefer apple to pumpkin. I would be one of those teachers. I do not care for pumpkin. So I would have chosen apple above that, okay? So there's a couple different ways we can approach this when we're looking at the information that we know, and we just have to kind of be smart about how we're comparing them. The last question here is, what is the degree measure for each sector of the graph? So what I need to do now is find the degree. Remember that there are 360 degrees total in a circle, and then each sector is going to be the percentage given multiplied by 360. So I'm going to start with the pumpkin because that's just the beginning where I found it, and I'm going to take 30% of 360. So I'm going to set up my proportion. 30 over 100 equals x over 360, and I'm going to cross multiply that. I end up with 108 degrees. So I'm going to write that in my chart here, 108 degrees. I'm going to do the same thing for cherry, except this time I'm going to have 23 over 100, and I'm going to cross multiply that, and I end up with 82.8 degrees. It's okay to have decimals when you're talking about degrees. Can't have decimals when you're talking about teachers, because a fourth of a teacher or 0.8 teacher would be kind of weird. But you can when you're talking about degrees. So it would be okay to leave this as 82.8. I'm going to do the same thing with apple, and I'm going to use 36 over 100 times 360, and I'm going to get 129.6 degrees. I'm going to stop and think about this for a second. Do these numbers make sense? Well, I know that apple is larger than pumpkin, and 129.6 is larger than 108, which is then larger than cherry, and 108 is bigger than 82.8. So my numbers seem to make sense so far. I'm going to move on and do the coconut cream and the pecan. So coconut cream is 3 over 100, and then I'm going to multiply that out, and I get 10.8. And then the last one is pecan, which is 8 over 100. Cross multiply that, and I get 28.8 degrees. Okay? So we're just figuring out the percentage using 360 as our total, cross multiplying, and then solving for the degree measure. Okay? I hope this makes sense for you. Again, if you have any questions, let us know. But circle graphs seem to be pretty easy. You're just kind of reading them, looking for information, and finding the degree measure or how many people or whatever in the situation. Have a great one.